All right, class, welcome to Friday and rainy. So we'll see how this all works out here. Hopefully you guys enjoyed your Wednesday. Did you guys enjoy your Wednesday? Or like,
Yes.
no?
It was the perfect timing to not have a day at school.
I
Okay.
do actually like being at home.
Awesome.
I needed a day. I slept in, I didn't wake up at 5:40.
Now that more people are here, any power outages on your house? Anybody? Going once,
Oh,
going twice?
I went out, but that's it.
Except for Mr. McCullough.
Yeah.
Oh, yeah.
Gotcha.
That was the time.
That's okay, he thinks the internet is a porno.
Go back. Inverse. All right, guys, inverse trig functions here. That's what we're looking at now. And my little thingamajig keeps on coming down here. Okay, you stay there. Okay. Boom. So first things first, what in the world is an inverse function in the first place? All right, let's go back to this right here. X squared is a fun one, just for an example purposes here. And you guys talk to me here. How many remember inverse functions? We did it in algebra. We did it in algebra too. Go ahead, Amaya. A little bit. Explain or a little bit. What do you remember?
I mean, I
You had your hand
remember
up.
that we did them. Well, it's just f(x) to -1, right?
Okay, yeah. So the notation for it, whenever you declare something to be an inverse function, you do f to the -1. That little -1 does not mean power of -1. That actually means reciprocal. No, that doesn't mean reciprocal. It means inverse function. Kind of funny. We kind of almost like in math, we start running out of notations. We good? So if you have this, if you have a negative in front of a number, that actually means negative. We good? You have a negative or -1 like this in the exponent, and that means reciprocal. We good? It means 1/3 eventually, right? And then if you have a -1 right after a function name, that means inverse. So we got 3 different things, same symbol for them, but they mean totally different things where they're at. Okay, so x squared. I think what we do is we do this. We to find the inverse function, we say that this is just a graph only. So we say instead of f of x, we just say that's y. And did you guys remember? Let's see, remember this here. And what we would do is we switch our x's and y's. Something like that. And then what we do is we solve for the y again. And once you solve for y, voila, you got yourself a inverse. And so in this case, you're going to have to square root both sides, plus or minus, right? So y is equal to plus or minus √2, or sorry, root of x. And then you say dun da da da. Oh no, you can't say dun da da da. Because is this a function? If you input one thing for x, right, and you get 2 things out, you're going to get a negative answer and a positive answer. Yeah, it's gonna fail the vertical line test. That's right. So this guy, if I were to graph it, if I were to graph a square root of x, it's gonna go somehow like this. Okay? And if I were to graph a negative square root of x, it's gonna go like this. Good there? So like 2 things to keep in our minds as we do this here. So first things first, Georgia says this is not a function. So, because it fails a vertical line test. So I can't make this y to be f inverse of x. Oh boy. So let's go back over here though. So inverse functions, what do we know about them? Is first of all, it's the switch of x and y. That's what we have. And the graph switches. So notice, we should notice a few things here. So notice I'll like right here at 1, 1. If you switch 1, 1, you're still going to get 1, 1. There's no change there. Over here, if you switch 2, 4, right? Because 2 squared would be 4, is that right? the graph over here, we didn't get to it here, but this guy would have been 4, 2. Okay, so it's the switching of the x's and y's. That's what makes the inverse function even, that's what makes the inverse even possible. The function part is the fact that this guy has to pass the vertical line test, which right now it does not. We're good? So question. Question, maybe. Oh yeah, and it does not pass the vertical line test because of this right over here. Remember, because this guy is -1, 1, and this guy is down here. There's my 1, -1 that I switched. Okay, are we good so far? And here's our little trick. You ready for the trick? What I'm going to do is I'm going to limit this little, we call it the domain. We're going to limit the domain of x squared so that when we do take the inverse, that inverse will be a function. Are we good? Too much for a Friday with rain? Or are we good?
Wait, what do you mean by limit?
So instead of graphing all of it, we're going to only graph a portion of it. And we're going to say that's what it is. So, oh, and one more thing from algebra. Do you guys remember this? If this guy fails a vertical line test, this guy's going to fail a horizontal line test. We good? So let's talk about that. Clarify that in our minds. A vertical line test is to find out if the function is a function. We good? A horizontal line test determines if you have an inverse function. Okay, that's something to keep in mind. We're good? So there's two things there. So we'll come back to it. And I think we're going to put it all together now in just a second here. With the lights down low, it feels like a movie theater. No one falls asleep, okay. All right, let's go for it. Let's go backwards in time just for a second here. So how do I know that this guy is going to fail a vertical line test? Based upon the graph itself. Yeah.
Because there's 2 outputs for 1 input.
If I did not have the inverse function yet, if I just had the regular function, how would I know that the inverse?
Because it fails a horizontal line test.
I think, are we good there? So if this guy fails a horizontal line test, you know that this guy's going to fail a vertical line test because it's just switching of the x and y's. Are we good? Mm-hmm. So we somehow have to make x squared not fail a horizontal line test. That's cool. All right, the way we can do it is we limit the domain. We're going to chop off a little bit of the function. So instead of going all the way down, coming all the way up, how about if we just use this side only? So we're going to say this is f of x squared. That's great. With the condition that x is greater than or equal to 0. All right, so talk to me after you draw it. Does this pass the vertical line test now? Oh, sorry, does this pass the horizontal line test? That's what I meant. Awesome, okay. So when we, yeah, I thought we did that. Okay. That passes the horizontal line test. Let's see. Now if I were to switch these around, so y is equal to x squared. I switch the x's and the y's, and I solve for y this time. I'm going to do a square root here. I'm going to do a square root here. I'm not going to put plus or minus because I'm only taking the positive values of x, correct? So it's just going to be the square root of x. So it's going to be like this. It's 0, 0, 1, 1. Let's even put it down. This guy's 0, 0. Here's 1, 1. I'm going to just make this guy to be 2, 4. This guy would be 3, 9. So that'd be kind of at least useful information. All right, can you guys graph for me the square root? So if I'm just switching x's and y's, 0, 0 still becomes 0, 0. In fact, let me switch pin color. 1, 1 still is 1, 1. 2, 4 now becomes about 4, 2, about right there, maybe-ish. And then I can't even graph 9. 9, 3 will be all the way over here, so I'm not even going to graph it. But are we good there? Sweet. Okay.
So because it can't be negative, it still is in the same quadrant. Whatever it's called.
So we're only using the positive x values. So then we're only using the, when we switch the x's and y's right here, then we're using only the positive y values. So it's only anything above the x-axis. Perfecto. Our original function of x squared with the domain restriction of x greater than or equal to 0, does that pass a horizontal line test? Everybody says yes on a Friday morning. And then, so that means our inverse graph has to pass a vertical line test. Does the inverse graph pass a vertical line test? Everybody says yes on a Friday morning. Okay, so we can finally declare da 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 da. Now we can do da 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 da. Da 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 da. The inverse graph that we have is truly an inverse function of our original graph. Whew, that was crazy, but fun. Now the question is, Mr. G, what does all this mean? What are you even talking about? So let's go with it here. The sine of x. We're going to have that guy. I think you guys know the graph of it already. In fact, I'll do a modified graph of it because I don't need all of it here. Let's do this one. I think here's sine curve. Tell me if you guys agree. Bless you. It keeps on going, is that right? I know it keeps on going. That's no problem. But the sine curve starts at 0, 0, right? Usually goes up, comes back down, and keeps on going. We're at 2 pi by the time it does that cycle. If you go backwards in time, we're at negative 2 pi. Are we all good there? You think so? Here's what I want to do. I want to create an inverse function of sine. Crazy. Mind blown. So first of all, let's think about what the sine curve does. So we have an angle, don't we? When we do this right here, when we say sine of, let's do an example here, sine of 30 degrees. And we say, haha, is, anybody know? .5 or 1/2, perfecto. So notice what the sine curve does. It takes a degree value, takes a theta value, right? And it turns into a ratio. That's what the sine curve does, or the sine function, right? Talk to me. What is a sine inverse function going to do? I think so. So somehow this little sine inverse is going to do this. It's going to do sine inverse of 1/2, right? And it's going to go from ratio, and we're going to find our degree value from it, right? It's going the opposite way. Okay. Just for us to understand, that's what inverse function is going to do. All right, so next, I want inverse function. Does this guy pass a horizontal line test? No way, no way. Okay, so that means I'm going to start chopping this off just like I did to x squared. So you guys tell me, I'm going to start writing this down. You guys tell me, where should I chop? From where to where?
Wait, so when it doesn't pass the horizontal line test, that doesn't mean that it doesn't have an inverse?
Correct, yeah, it does have an inverse, it's just the function itself is not inverse, so you don't have an inverse function. Boom, okay, you guys talk to me, where should I chop? You guys are smart. You do not have to start at 0, no, you just need to have a starting point, ending point somewhere it's not going, that passes a horizontal line test. That's all I need.
You can do it, negative pi over 2 and pi over 2.
Yeah, that would be good. See if you guys agree here. All Karina's looking at is the lowest point on the graph, right? And as you start going all the way up, you get to the highest point on the graph, I believe. Is that how you did it? And you're done, right? There's no more to do. So what we're gonna do is we're gonna go like this. We're gonna chop off the rest of this off. Chop the rest of this off. Okay, so then we're gonna have to graph, and let me graph it on different piece so it's not as looking crazy here. So let's see. So now we want to graph it here. So here's what we're going to do. First of all, let's see. Pi divided by 2. Pi is 3.14. Divided by 2, I think it's 1.57. Is that right? Ish. I looked it up. I know it. Just kidding. Okay, so negative 1.7. So the way we're going to graph it is we're going to go out to, oh, now, you know, this one goes out to 1 only, right? Because notice where we're switching this and we're switching this. Let me put dots on it here. So this is going to be pi over 2 comma 1, right? Bless you, bless you. This is 0, 0. This is negative pi over 2 comma negative 1. We're good? So we'll have to switch this around. So now the point that I want is actually 1. And here's pi over 2 is about right here. So the point here that I want is now 1 comma pi over 2.
So you can flip the graph as well, like the table.
You can flip the graph. I'm just flipping x's and y's, but yeah, I forgot to bring in a little something here, but on Monday, when we're going to be here, I'm going to bring a little flipper doodad thingamajiggy. How's that for a specific name? And we'll see. We'll see what that looks like when we flip it around visually. Okay, 0, 0 still on here, is that right? Now we're going to go negative 1, and we're going to have to go down 1.5. So a little bit about there. That's a negative pi over 2 right there. Okay, boom. So here's what I got. Notice the curve on here is kind of horizontal-ish right here, right, on the original graph, right? It goes like this, and then it comes down. So this one's going to be more vertical graph. So here it is. It's going to go like this. And boom, there it is. Guys, we are awesome. We have just graphed an inverse sine function. It totally has some domain restrictions on it, but that's fine. Now let's do the notation for it. Are you guys ready? So y is equal to sine of x. I think what we do this, we change our x's and y's, right? And what we do is we have to send this sine function to the other side. Well, we got ourselves a little problem. We don't just do what we did before. We just square root both sides and we're done, right? What we do is we're just going to make a little symbol saying we're going the other way. And that little symbol is going to be sine inverse of x. That's our little function. And then we're going to also declare that's the inverse function. So we're going to say sine f of x, f inverse of x. We're good there. So we declared that to be a function itself. Okay. Let's do real quick here for the time remaining here. Let's do, yeah, and then we'll do a quick one on the end here. Let's do cosine. I'll let you guys think about tangent, cotangent, secant, cosecant later on. And then we're going to do some problems with it here. So next is cosine. So here's my function. My function is cosine of x. Here's my graph for cosine. Can we figure this guy out? It's raining a little bit more. 2 pi divided by 2 3 pi over 2 negative 2 pi. Negative pi, negative 3 pi over 2, negative pi over 2. Da, 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 da. Not a very nice graph, but we'll go with it. So question is, does it pass horizontal line test? I don't think so. Where can we chop it so that it would pass a horizontal line test? Oh, I go with it. Yep. Georgia says from 0 to pi because 0 is the high point, pi is the low point. So this one's a little different, huh? So chop, chop, chop everything else here. Chop, chop, chop everything else here. So let's see. Let's go with it here. I'm
Wait,
gonna.
so can you explain again why you go from the high point to the low point?
Because if we were not to chop this off right here, then it would not pass a horizontal line test.
Okay.
And we need it to pass a horizontal line
You need it
test.
to be positive, you're,
Oh, yeah, that's true. Here, so real quickly here, Grace, thanks for mentioning it here. So in mathematics, it doesn't necessarily have to be from 0 to pi. It could go from negative pi to 0, but then do you really want to deal with negative numbers all the time? Like, not really. So what we do is we kind of pick the most convenient interval in order to do that in. In fact, kind of funny, when I was in school, cotangent interval, we'll take a look at it Monday here as an extra. The cotangent interval was one way when I started college, and it was different when I finished college. It was the strangest thing. So, how's that for fun? Oh, what? These guys have not figured out mathematics? Come on. Okay, are we good there? So we have to be between 0 and pi. I go with that. We're going from 0, 1. Let's see, pi over 2 comma 0. And we're going to, this little dot right here is at pi comma negative 1. So let's go with it here. I think it's going to be negative 1 here, positive 1 here. Nope. Let's see. Brain freeze. Hold on. Yeah, okay. And so we're going to go from 0 to pi. So at negative 1, we're at pi. So this is 1. Pi would be, whoa, pi is all way up here, isn't it? That's 1. That's 2. That's going to be 3. And we're at 3.14. We're about right here. Everybody agreed there? This guy is negative 1 comma pi, which is the opposite of this guy here. Okay, everybody good there? So as it comes down, so this is 3.14-ish right there, negative 1. It comes down, we're at 1.57, so we've got right here. So this is 0 and pi over 2. And then here, we're going to be at 1 comma 0. Okay, so here it is. It comes down like
so
this.
why this time did you not write the graph the same as just like pi over 2, pi, 3 pi over 2 for each mark? Like you did the other one.
Let's say that again, Grace. Say again.
So for the graph for the sine one, you still had, I mean, unless I did this wrong, but you had each mark was like pi over 2 was the second dash.
This one here? Yeah, let's go over here. So this guy here on for sine, it got transferred into this dot right over here.
I think she's asking like why on the first one you were saying like pi over 2 and pi, and then on the second one you were saying 3.14 and 1.57.
Like for your Y scale, why you went from radians to.
Yeah, Shabril.
Oh, I think I did it here too. Let's see. So this is my little 1 right here, right? And this is about 1.57. So I scaled it according to real numbers anyways. Is that okay? Does that make sense?
Yeah.
And you guys, please ask me the questions here. because this is part of learning. This is, I understand that you focus on something like, hey, what happened? And that's okay, totally okay.
So even though we're switching it the opposite way and going from ratios to theta, we wouldn't draw radian measurements on the y scale, even though we normally would on the x scale if we were doing negative or regular.
Yeah, that just
Sine.
confuses me.
That's okay, gotcha. Okay, so when I flip them around, I still wanted to give you guys a perspective of where one would be. And then I gave you the radian measurement here,
Okay.
because I at least wanted the perspective.
Right, and that would be like the same thing that's normally going on the x-axis when we're graphing the sine, we just don't think about it.
Yeah, correct.
Okay.
Yeah, so for pi over 2, even though we don't think about it, we still think of 1 being right here.
Okay, so like if we graphed it and we just said like pi over 2 pi, that'd be like, okay.
Yeah,
Okay.
absolutely.
Okay.
And we usually don't graph inverse functions. That's not the main point of inverse functions. Main point of inverse functions go from ratio back to degree measurements. That's the issue. Okay, I'll let you guys do tangent later on. Secant, cotangent at home. What we want to get to is this little part right here.
Wait, so the inverse was cosine negative 1x?
Yeah, so if we wanted to do this one, this would be f inverse of x would be cosine. And again, all we've done is that little cosine to the -1, that is just notation for us. We good? That just because we can't write it any which way in that. So, all right. Now let's go to exercise 1. All right, maybe before we do that, let's do this one. One little extra piece over here. Do you guys remember if we were to go back on the unit circle, right here, this is important to note. You guys tell me, where would negative pi over 2 be along the unit circle? And where would pi over 2 be as far as an angle measurement? So remember how angle measurements on this side, this would be 0, is that right? And if we went up to here, this would be anglement of pi over 2. Are we good? So if I were to go down this way, this guy would be angle measurement of negative pi over 2. Are we good? Notice the inverse function. It on the x scale, it goes from -1 to 1, right? But notice in the y scale, sorry guys, that's me. This goes from negative pi over 2 to pi over 2. Are we good? So here's what I want you guys to notice. That the inverse function does not operate everywhere like the sine function does. It only operates in quadrants 4 and quadrant 1. If it's positive, it operates in quadrant 1. It's all this piece right here. If it's negative, it operates in quadrant 4, but it's not the usual measurement that we think of. It's not going up to 360. It's the measurement. Let's see, 1, this would be 2 over here. 3 would be right here. And so this would be quadrant 4.
Wait, I thought you circled the one on the lower graph, like
Right here. Oh,
Yeah.
gotcha. Yeah. So there's two things happening here. So this graph here, I'm trying to take it back to the unit circle again.
So
And
you're
so-
not saying that that's in quadrant?
No.
Oh.
I'm
okay.
saying this angle measurement right here, negative pi over 2 is the lowest we go. But negative pi over 2 is actually going negative angle, right, on the unit circle. And we're stopping when we get to this part right here. So inverse function for sine only operates in quadrants 4 if it's negative, 1 if it's positive, but the angle measurement's negative. We good? So we go from negative pi over 4, negative pi over 3, right, and negative pi over 2. That's kind of our scale
For sine.
for sine.
Can you say that again?
Sure,
Yeah,
sure.
I'm a little lost.
Sure. So based upon our angles that we have here, right? Because our y values, for our inverse sine function, they operate from negative pi over 2. Maybe this would be a better to pi over 2. I just saw that as I saw this graph. It goes from here to here. The lowest point is negative pi over 2. Highest point is pi over 2.
Oh, okay, so that's
So-
where it operates to form a inverse function that is actually a function.
Correct.
Okay.
So now the question is, if you go back to unit circle, what does that mean in terms of a unit circle? It means you're starting off at the bottom negative pi over 2 and you go up to the top. So only quadrants 4 and 1. Okay, are we good there? And we can, let's try cosine. You guys talk to me. What's the, in fact, let's do it this way here. What's the y scale? It goes from where to where? What's the lowest y form? What's the lowest y number? 0. And it goes up to pi. So cosine works in quadrants. You guys talk to me. 1 and 2, are we good there? So here's 0, right? This is our starting point. Our ending point is pi, so that means it goes here. So cosine works in quadrants 1 if it's positive, quadrant 2 if it's negative.
Oh, so it's just how far the range is.
For it still to be a function. Okay, so now with 2 minutes left in class, let's do exercise 1. And okay, 3 minutes left in class here. We evaluate the expression. So I'm not going to get to the tough questions. There's a few little tough ones here. I'll let you guys try them. We'll talk about them on Monday. We'll just finish up with those. So let me just kind of start it off real quick here. I need to know this. Sine inverse of 1/2. And so you think back, remember we have the graph of them, right? But we think back to the unit circle and we ask ourselves, hey, when is sine 1/2? It's positive, so we're looking at quadrant 1 and we're looking for this guy. We're looking for a 1/2 along the y-axis and we're trying to go back to our theta. What's our theta that makes 1/2? 30 degrees. So now, say again, say again. Oh yeah, and that's our little problem. Remember, for this to be a function, it's only going to operate in quadrant 1 and 4. That's why we have to have the limit. Otherwise, we're going to get over here as well. Okay, on the homework, it could either say give the answer in degrees, or it could say give the answer in radian measurements. We're good? So you have to be mindful of that. Okay, the other one, and we'll finish off with this.
Just 30?
30, that's it, 30 degrees actually. Done, we're going backwards.
Basically, all you're seeing is, you see sine, inverse of sine, wait, times 1/2, you just remember that, okay, that's a 30-degree angle there.
Yeah, and then probably
Is that how that is?
Yeah, it's right on the back. That's it.
you're gonna be looking at your unit circle.
And that's why I always breathe with me. Rather helpful.
Okay, and 45 seconds left. The old way we used to say it, instead of saying sine inverse, we used to say it was arc. And arc really means the same thing as, so arc sine would be, and then we
I
could,
was looking at the chapter before and I was so confused when I saw that.
be confused no longer. We're good. No, that's the old way of saying it. It's
So
still
arc is
textbook.
pretty much just sine, just -1.
Yeah, sine. Yeah, it's, we don't even say, we don't say even sine -1, we say inverse sine.
Yeah.
All right, guys, what's inverse sine of -√3/2? So Adrian, help us out. I think it has to be in quadrant 4, right? This right here, right? It's gonna be somewhere here. And we're looking for when the y value is -√3/2.
60 degrees or -60.
Yes, and careful not to put the angle measurement that's on a unit circle. It has to be the angle measurement that's going the negative way. We good?
300 degrees, I believe.
Okay, and then you have to take the negative of it. So it's not 300, it's,
I'm saying sadly can't say that.
And guys, we're out of here. I'm gonna stop there. We have just a few little nuances to finish here, but, and also with the calculator, you should find a calculator button that has sine to the -1 on it. You guys can use that. But let's take homework questions on Monday of next week.